Chapter 6 Momentum. Index. Momentum. Conservation of momentum, collisions, impulse and momentum change, explosions, rockets and jet engines, recoil of a gun, applications in sport and safety, stopping a moving object, worked examples. Momentum. Definition. Momentum is the quantity of motion possessed by a moving object. It depends on both the mass and the velocity of the object. Formula. The formula for momentum is momentum P equals mass m multiplied by velocity v. Units. The SI unit for momentum is kilogram meters per second. It can also be expressed as Newton seconds. Key properties. Momentum is a vector quantity, which means it has both magnitude and direction. The direction of the momentum is the same as the direction of the velocity. Conservation of momentum, principle of conservation. In a closed system where there are no external forces like friction, the total momentum before an interaction is equal to the total momentum after the interaction. This applies to events like collisions and explosions. Applications. This principle is used to understand collisions such as car crashes. Explosions, like a rifle firing or a rocket launching. The recoil of a gun when a bullet is fired. Mathematically, the principle of conservation of momentum is expressed as total momentum before equals total momentum after. For two objects interacting, the formula is m1 times u1 plus m2 times u2 equals m1 times v1 plus m2 times v2, where m1 and m2 are the masses of the two objects. u1 and u2 are their initial velocities before the interaction. v1 and v2 are their final velocities after the interaction. Collisions. A collision is an event where two moving bodies interact and experience a sudden impact force. Collisions are classified into two types based on whether kinetic energy is conserved. A. Elastic collision. In this type, both momentum and kinetic energy are conserved. An example is the collision of gas molecules. The inelastic collision. In this type, momentum is conserved, but kinetic energy is not. Examples include a car crash or a ball of clay hitting the ground and sticking to it. Practical work. To study collisions, you can set up two trolleys on a ramp with photo gates. Velcro strips can be added to make them stick together after the collision. You can measure the velocity before and after the collision using the formula velocity equals the length of the trolley divided by the time it takes to pass through the photo gate. You can then verify the conservation of momentum by comparing the initial and final momentum. For a moving trolley hitting a stationary one, the formula is m1 times v1 equals the sum of m1 and m2 all multiplied by v. Impulse and momentum. Impulse is the change in momentum caused by a force acting over a period of time. The formula is impulse equals F multiplied by t, which also equals the change in momentum, delta p, calculated as m multiplied by the change in velocity, v minus u, where F is the force in newtons, t is the time in seconds. Delta p is the change in momentum. Applications. Airbags in cars increase the time of impact, which reduces the force on passengers. A cricketer moves their hands backward while catching a ball to increase the time of impact and reduce the force. Explosions. In an explosion, objects move apart suddenly from an initial state of rest. This is caused by internal forces, and momentum is conserved throughout the process. Before the explosion, the total momentum is zero because all parts are stationary. After the explosion, the objects gain momentum in opposite directions. The momentum of one object is equal and opposite to the other. This is shown by the formula m1 times v1 equals negative m2 times v2. Therefore, the total momentum after the explosion is still zero. Rockets and jet engines. Rockets and jets operate on the principle of conservation of momentum. By expelling high-speed gas backward, they gain an equal amount of momentum forward. To conserve momentum, the rocket must move in the opposite direction to the expelled gas. The rocket gains an equal and opposite momentum, so the velocity of the rocket can be found using the formula vrocket equals the mass of the gas multiplied by the velocity of the gas, all divided by the mass of the rocket. Recoil of gun. Recoil is the backward movement of a gun when it is fired. This happens because of the conservation of momentum. Before firing, the total momentum of the gun and bullet is 0. After firing, the forward momentum of the bullet plus the backward momentum of the gun must still equal 0. This means the momentum of the bullet is equal in size to the momentum of the gun. The recoil velocity of the gun is given by the formula vgun equals the mass of the bullet times the velocity of the bullet, all divided by the mass of the gun. Applications in sports and safety. Sports. A follow-through in tennis or cricket increases the contact time, which creates a greater impulse and gives more momentum to the ball. When catching a ball, drawing the hands back increases the time of impact, which reduces the force and helps prevent injury. Safety features. Crumple zones in cars are designed to increase the time of impact during a collision, reducing the force on the occupants. Seat belts and airbags work in the same way to lower the risk of injury. Stopping a moving body. The force required to stop a moving object depends on two things: its momentum, the time over which the force is applied. An object with larger momentum will require more force or more time to stop. For example, to calculate the force needed to stop a 2-kilogram object moving at 10 meters per second in 5 seconds, F equals the change in momentum divided by time. This is 2 multiplied by 0 minus 10, all divided by 5, which equals negative 4 newtons. Worked examples. Example 1. The velocity of a 10-kilogram object increases from 4 meters per second to 8 meters per second when a force acts on it for 2 seconds. Find the following. A. Initial momentum. This is 10 multiplied by 4, which equals 40 kilogram meters per second. B. Final momentum. This is 10 multiplied by 8, which equals 80 kilogram meters per second. C. Momentum gained. This is 80 minus 40, which equals 40 kilogram meters per second. D. Value of the force. Force equals the change in momentum divided by time. This is 40 divided by 2, which equals 20 newtons. E. Impulse of the force. Impulse equals force multiplied by time. This is 20 multiplied by 2, which equals 40 newton seconds. Worked examples. Example 2. A boy hits a stationary billiard ball of mass 30 grams with a cue. The cue is in contact with the ball for 0.001 seconds and exerts a force of 50 newtons. A. Calculate the acceleration. First, convert the mass to kilograms. 30 grams is 0.03 kilograms. Using the formula F equals m times a acceleration that equals force divided by mass. This is 50 divided by 0.03, which is approximately 1,666.7 meters per second squared. B. Work out the impulse. Impulse equals force multiplied by time. This is 50 multiplied by 0.001, which equals 0.05 newton seconds. C. Calculate the velocity after being struck. The impulse equals the change in momentum. So velocity v equals the impulse divided by the mass. This is 0.05 divided by 0.03, which is approximately 1.67 meters per second. Thank you for learning with us.